In Chapter 8, we're going to take a more in-depth look at how to operate with strings. Up till now, we've looked at strings as a whole object that you add strings together and print strings. But it turns out that there's also methods to get inside and pull the strings apart. So string indexing, like any other array or list object in a computer programming language, starts at 0. So you use the bracket notation to give you an index into the string, and then at place 0, we're going to find the letter capital A. I've actually run the program so you can see that when I do print s of 0, I get A down here. Because the index starts at 0, the last index is actually going to be the length of the string minus 1. So this should give us the very last character in this string. Oops, that was weird. The lowercase z, which it does. We can also go and pick out other elements of the string. So if we go to index 4, then that'll be A, B, C, D is 0, 1, 2, 3. 4 is actually going to give us a capital E. 5 will give us a capital F, 6 a capital G, and 7 a capital H. So S4 is actually going to give you the 5th element of the string. We can print each one of those out separately, and we did that down here. We got the E, F, G, H. Or you can take a slice of the string, which is done using this colon notation. So S4 colon 8 is going to give you the elements from 4 up to 7. So like in the range case, you go to 1 less than this last number. You can also do indexing from the rear of the string. If you go minus 3, then that will start at the rear of the string and back up 3 elements. And this will then take us from minus 3 up to the length of the string minus 1, which would be at z. So this should print out XYZ, which it does. And I kind of gave away a secret down here, but I created a new string using elements of the old string, which I pieced together one by one. And we printed out the ubiquitous hello world. So 7 corresponds to a capital H, 30 to a lowercase e, and so on. Put a space in between, and then print it out S2. The idea here is that you can build up new strings from old strings using string indexing or string slicing. In this case, I took a slice from 12 to 20, called it V, and then we could use V as any other string. In this case, I just printed V out, and it turns out to be the capital letters from M up to T. Okay, so a quick introduction to string indexing and slicing, and then we're going to go over here to loops and strings to see how you might use this idea. So alphabet is the same string that I had in the previous example, and I'm going to write a couple of procedures. Where is and count. So where is going to look through any string, in this case alphabet, and we're going to pass in a character, and we're going to look to see if we can find that character in the string. And the way I'm going to do this is I'm actually going to look for upper and lowercase versions of this, so I should get the capital A and the lowercase a. And the way we're going to do this is we're going to start off at the beginning of the string, go all the way to the end. We can do that using a range because we know the length of the string. There's a command that computes length of string. And we're going to just test to see if this character is equal to the character that's at the index. So we're going to have a for loop that goes all the way through the string, and we're going to just compare with that index. So let's go up and take a peek at where is. We pass in a string to where is and a letter. This is the string we're going to search, and this is the letter that we're looking for. The positions we're actually going to print out as a character string, so we start off with the empty string, and then here's the loop that I talked about. We're going to go from a range of 0 up to the length of s minus 1. So we check then if the string at the index I, and we convert it up to an uppercase, so we're comparing uppercase to uppercase. This is the letter that we passed in. And if those two are equal, then we're going to add that position into our character string, and we check to see if we're have the empty string to begin with, so if this position is empty string, then we're just going to put that index I plus 1 in there. Otherwise, we are going to put a comma and make it a comma separated list. So this one's going to be the first element in the list, no comma, and then these will be the other elements in the list. And then we're just going to return that string. The other thing we're going to do is count the number of instances in a string. So this is going to be the same sort of thing that we did up above, except for instead of returning a string, we're going to return a count. So we start off with a count of 0, same loop, and we're checking upper against upper. So we're going to get all instances of the letter, whether it be uppercase or lowercase, and then if we encounter the character in the string, then we're going to add 1 to our count, and then we're going to return C. So we're going to return A on alphabet, and we're going to return I in the word Mississippi. Of course, we have to run the right program to make that work. So I'll come up here and run loops and strings. And so A is, remember I added 1 up here when I did this. So I did string I plus 1. So this is giving us that A is the first letter in this string, and it is the 27th letter. 26 letters in the alphabet, so this would be position 27. And there are, there should be 4 I's in Mississippi. What did I do wrong? Let's see. For I in range, length S minus 1. Oh, I wonder if I'm missing the last one here. Oh, range. I got caught on range again. So range, and these both should be length S. So I got caught because the I is the last letter in Mississippi, didn't I? So range goes from 0 up to 1 minus this, and I had length S minus 1 in there. I was only getting up to the last P when I did this. So if I had tried running where is with Z with the way it was before, let's put it back. I actually didn't do a good job of testing my code. And I'm going to leave this mistake in there. I guess I could just edit it. Oh, now what did I do? Oh, well now I'm really screwing up. I meant length S minus 1 with the 1 on the outside. Now I'm just going to go ahead and leave these mistakes in here instead of editing them out. I've been getting some complaints that my videos are actually a little too perfect, so my students are wanting to see me screw up. If I run this with a Z, I'm actually not going to get the last position. I'm only going to get to 26. So I really want to go up to length of S here. And now we should get the right thing. So 26 and 52, and there are 4 I's in Mississippi. So hopefully my mistake didn't cover up the fact that what we're really looking at is that you can use for loops in conjunction with string indexing to go in and look for pieces of the string. There's actually built-in Python code to do this, but I think it's illustrative to see the kinds of things that you can do. There was one last thing I wanted to show, and I actually have this commented out below. And this should be alphabet. It would be interesting if you could set alphabet sub 0 to be D, so that this string would then be D, B, C, D, so on. But it turns out with strings, you can't do that. So if I run this, I actually get an error. String object does not support item assignment. So you can't, once you assign alphabet to be this string, you can't change it in this way. So that's just bad, not going to happen kind of thing. We're going to talk about more later in terms of strings and things that you can't do with them. Strings are called immutable in the Python language, and this is our first instance of seeing that strings are in fact immutable. I don't like seeing the error there, so we're going to run this again without the error. Okay, And that is it for this lesson.